Hello, good day, everybody. Welcome and thank you for joining us for today's Embodied Carbon Networks 2018 webinar series. Today is the 5th session of an 8-part webinar series, and it will focus on building materials reuse. We have several exciting speakers joining us today who will highlight guidance, initiatives, tools, case studies focused on better materials decision-making throughout a building's life cycle. My name is Tina Delegi. I am a program manager at the Carbon Leadership Forum, and I'll moderate today's session. Please note that this webinar is being recorded and will be made publicly available upon its completion. So many of you joining us today are already members of the Embodied Carbon Network. We do have guests listening in who we invite to learn more and join the network. So the Embodied Carbon Network is a communications and knowledge sharing platform launched in January 2017. The network brings together individuals working in or with the building sector together to share resources, engage in discussion, and organize to take action. The network has evolved into a vibrant, engaged global community. To date, we are just over 300 professionals from across the building sector, academia, nonprofit, and government groups representing 92 cities across the world. While on the ground, our work to track and reduce carbon emissions may manifest in different types of research and development, technical work, tool building, education, and outreach. At the network, we connect under a shared mission to eliminate emissions from the built environment in order to meet carbon neutrality targets by 2050. Our members participate in different task forces, as you can see here, and the task forces are organized around specific topics, and people can join one or as many as they'd like, and even create new task forces. So these are spaces for focused discussion, a platform for people to talk in more detail about their work. And I'll add too that our task forces have been the ones driving the development of each one of the webinars. So the Embodied Carbon Network was convened by and is supported and managed by the Carbon Leadership Forum, or the CLF. The CLF is an industry academic collaborative led by Kate Simonin, based out of the University of Washington. It carries out research, education, and outreach initiatives focused on embodied carbon tracking and reduction. So thank you to the CLF and its sponsors for supporting the network and this webinar series. Again, today's webinar is the 5th session of an 8-part series. Each topic, as I said, is based off task force topics, and task forces are the ones recruiting speakers and developing content. This is part of our goal to increase knowledge and provide educational resources around embodied carbon in the building sector. Our network has a real depth of knowledge and expertise, and the webinar is just one of hopefully many initiatives that we will lead to help leverage and translate this knowledge more broadly. So we hope that these webinars will not only be useful to those attending today, but also serve as free educational resources in the long term for anyone who's interested in learning more. So please feel free to share webinar recordings with your colleagues, networks, and students. And please note too, if you are an AIA member and you need educational credits, this course is eligible for live attendees to receive credit. I'll provide my email address at the end. Just send me your name and member number, and we'll go ahead and get you credit. So we have 3 presentations today, and then a 10 to 15-minute question and answer session at the end. So if you have questions during presentations, please submit through the GoToWebinar question function. I will be tracking questions and then directing them to the appropriate speakers at the end of the session. So from 10 to 10:15, we'll have Q&A. So today we are joined by speakers and our reuse task force chair, Larry Strain, principal at Siegel & Strain Architects, Dave Benning, he's an owner at Reuse Consulting, and Brad Guy, an associate professor at the Catholic University of America. So Larry is going to kick us off today with an overview of why reuse matters. Dave's going to talk about the avoided impacts from materials reuse compared to making new materials. And Brad is going to take us through some of case studies and tools to measure the benefits and impacts of reused materials. So with that, I'm going to hand over to Larry now to share his screen and slides. Okay, Larry, you should be able to share your screen. Great.
Okay. You see it now. I'm going to put it on full screen here.
And sorry, Larry, while you're doing that, I'll give you a better introduction. So Larry Strain is founding principal at Siegel & Strain Architects in Emeryville, California. He's spoken on materials and sustainability at conferences throughout the country and is author of the Resourceful Specifications, one of the first guideline specifications for green materials. He is currently a member of the AIA Materials Knowledge Working Group and serves on the boards of the Ecological Building Network and the Carbon Leadership Forum, and he's chair of the Reuse Task Force of the Embodied Carbon Network. He was on the research team for the Embodied Carbon Benchmarking Project and is co-author of the Total Carbon Study, a white paper on the time value of carbon, and he contributed a chapter on reuse to the New Carbon Architecture book. For the last decade, Larry has focused on reducing the total carbon footprint of buildings. So thank you, Larry. We can see your screen. It looks great. Take it from there.
All right. Thank you, everyone. Welcome. So I think reusing buildings and materials is inherently more sustainable than tearing them down and building new ones. We also think it's one of the key strategies for addressing climate change. Hang on a second. Okay, here we go. So as a reminder, this is what we're trying to save. And when we're trying to save that, usually we think about saving this, which is well worth saving. But the point is, it's not just a natural world we need to save. We need to also save this, the cities, the people, everything we've made, not just because they matter to us and because we're part of it, but because they're the resources that we think we need to save the planet. So existing buildings represent an enormous opportunity to address climate change. We have a lot of them. They use a lot of fossil fuels, and we can't afford to replace them both economically and from a carbon point of view. But if we keep them and make them more efficient, we've got something. So as a reminder, this is what we need to do to keep global warming under control. We need to try and get emissions to peak by 2020, stop burning fossil fuels completely by 2050, and start sequestering greenhouse gases out of the atmosphere now. So there's a time value in that scenario to carbon emissions and carbon savings. And what we need are strategies that save a lot of carbon and strategies that save it now, not 20 years in the future. And this chart illustrates why carbon saved now is more important than carbon saved in the future. The blue line shows a 10% reduction every year. The red line shows starting out kind of slow, and then as we start to panic, we increase the rate of reduction. The green line shows starting out fast, and as it gets harder to save carbon, we can decrease the rate of reduction. The area under each line represents the total carbon emitted over time. So the faster we can start and the more immediately we can save carbon, the less carbon we emit. So this is just sort of an illustration of that. And operating existing buildings represents one of the largest sources of greenhouse emissions, so that's how to save a lot. And embodied carbon, which is the materials in buildings, is also the first emissions that a building's responsible for. So it represents a way to kind of jumpstart this. So it's a heavy hit early on. So to give you a big picture, globally, emissions from the built environment are about 40% of total emissions. 11% of that is from embodied emissions from building and construction, and 28% is from operating emissions, and that's operating all of the buildings we already have. So the point is, the existing buildings are the problem for operating emissions, and the new buildings are the problem for embodied emissions. We have about, you see the numbers there. So one way to reduce embodied emissions is to build fewer new buildings. And when we upgrade existing buildings, we can lower operating emissions. So another big picture slide. In 2017, the world had about 230 billion square meters of buildings. That's the yellow bars on the right. The blue bars and black bars on the left is what we're projected to build between now and 2060. And we're expected to double the amount of buildings we have by 2060. And in the longer time frame, say between 2040 and 2060, most of that growth will be in Africa, followed by China and India. But in the shorter time frames, which the time value of carbon reminds us is the most important, between now and 2030 is really important. And in that time frame, most of the new buildings will be in China, followed by North America and Europe still. So the black bars, you can see China, North America, and Europe have the largest black bars, which is between now and 2030. They're also the areas of the world that have the most existing buildings. These two facts, in my mind, represent a real opportunity. If we can, so over the next decade, the parts of the world that have the most buildings are also the places that we're building the most buildings still. So if we can reuse more of the buildings we already have, that might allow us to build fewer new buildings, which would save embodied emissions. And if we can make the existing buildings more efficient, we can reduce emissions from existing buildings. So on both sides, those three areas, China, North America, and Europe, are three huge opportunities for both saving embodied carbon and saving operating carbon from existing buildings. And I'm going to talk a little bit about energy consumption because it relates to this idea of upgrading existing buildings. Overall, our buildings are getting more efficient, but unfortunately, energy savings on the right aren't keeping up with the increased demand on the left, which is driven by increases in population, floor area, and increased energy services. More people are getting power to their houses and things like that. A lot of energy savings on the right are because of new buildings. It's not because we're making existing buildings more efficient. One trend that can help lower emissions from new and existing buildings is decarbonizing the grid, and that's happening at a rate faster than we thought would happen. So that's the good news. So envelope and technology improvements, which is the areas in yellow and green and up there, will continue to be important, but the biggest reductions may come from just cleaner electricity. And for buildings to take advantage of cleaner electricity, we need to stop burning fossil fuels for heat and make our buildings electric buildings, which includes in converting existing buildings to be all electric. So overall, the UN report, this is from the UN Environment Status Report from 2017, says that we need to reduce total new emissions from buildings by 30% to stay below that 1.5 to 2 degree threshold we're trying to stay below. So more reuse plus upgrading more existing buildings coupled with a cleaner grid might just get us there. So here's the emissions we're trying to reduce for new and existing buildings. So new buildings, operating the new buildings we're building every year is not a ton because we're not building that much per year. We're building the new buildings we're building every year is about 4 gigatons. So if we reuse and build fewer, that brings that down. And then upgrading our existing buildings, that's got a 10 gigaton potential to reduce. So that's key. So to reuse more of what we have, one thing we need to do is identify where the opportunities are. This is from the Atlas of Reurbanism from the Research and Policy Lab of the National Trust for Preservation. And it mapped, I think this is Philadelphia, it mapped areas where older, denser neighborhoods are sort of prime candidates for reuse. The red areas represent blocks of older, smaller, mixed-use buildings, which lend themselves to reuse. The blue areas are newer, larger buildings that may be more difficult to reuse. We also have to figure out how to upgrade more buildings. So reuse is one piece of it, upgrading what we have is another piece of it. The Rocky Mountain Institute has done really good work in this area. These are some of the strategies they've developed for commercial clients. And on average, they were able to improve building efficiencies across whole portfolios owned by large clients by 30 to 40% on average by taking these various strategies and applying them. That's great. We probably have to go even farther than 30 to 40%, but a 30 to 40% reduction in existing buildings is huge. There's for residential buildings, there's also incentives and rebates from utility companies, which are not enough, but they're there, and we need to focus on how to make that happen faster. And these are just some of the resources for those slides, which will be in the slideshow, which you'll be able to download later. So I'm going to quickly go through, there we go. A quick case study, which talks about reuse and upgrading, which as a complete greenhouse gas reduction strategy. These are the DPR offices in San Francisco, which is a net zero remodel of an existing building. And after it was done, we didn't do the building, but we did a study with Indigo Group sponsored by Ecological Building Network and Stop Waste, on the total carbon impacts of this remodel. And we reused a whole lot of the structure. What we found was that the hatched bars show all the materials that we reused, and the solid bars are what we had to put into this remodel. And what this represented was about a 70% reduction in embodied CO2 over building a new building. So that was a huge amount. And even when we added in the PVs and mechanical systems, which weren't in this tally model that we built, which doubled our embodied carbon, the added carbon from building PVs and MEP paid for itself in about 4 years of operating energy savings. So the total carbon reductions, we switched from a gas electric building to an all electric building. So getting rid of the gas took out about 1,000 tons over 20 years. Energy upgrades and adding PVs took out about 4,000 tons. Reusing the building took out about 650 tons, and the total carbon reduction over 20 years was almost 6,000 tons. So it's pretty significant. This was just a small 2-story commercial building in San Francisco, and it wasn't even an ideal candidate for a net zero remodel. It had shaded areas, and it still worked fine. We didn't even upgrade the building envelope very much, and they got to this kind of savings. So that's great. So I've been talking a lot about reusing and upgrading whole buildings, but that's not always possible. But we can still salvage and reuse the materials. And since most of the embodied emissions from construction are in the materials, this is critical. So I'm going to turn it over to Dave Bennick now to talk about salvage and reusing materials. Thanks.
Great, thank you so much, Larry. So our next speaker is Dave Benning of Reuse Consulting. Dave has trained groups in 43 states and 4 provinces, helping start new sustainable businesses and diverting over 98 million pounds from landfills. He focuses on helping lower income homeowners, green collar job creation, historic preservation, and sustainable building. Reuse has completed over 980 deconstruction projects and has worked on over 3,500 total projects. To keep in practice, Benning also runs a deconstruction contracting firm, markets his reclaimed wood, and salvages and sells mature landscaping from job sites. Voted National Deconstructor of the Year, he also recently won a Sustainable Leadership Award in 2015 and 2017 National Reuse Educator of the Year. Benning has worked on many types of buildings, including commercial, residential, industrial, institutional, and more, including work for cities, counties, state, and federal agencies. So I'll hand over to Dave now. We can see your screen, and take it away. And Dave, note too that you'll have to unmute yourself. Okay.
Okay. So so I'm going to take off from where Larry left off. As far as, you know, he made the case of reuse, I think, quite well. And so we're going to assume that we've made the decision on a project that some reuse should happen. Maybe the whole building should be reused, but reuse is a priority. And that's not true on a lot of projects. Reuse isn't considered, and often until the very last second, which is ironic because reuse is usually one of the first things you need to consider. So we've made the decision to reuse. What is it that we need to do? Well, the first thing we need to do is be creative. I think that's one of the key points of what do you do with this material? How can you reuse it? Is it in some practical way? Is it in some artistic way? Is it an aesthetic? Is it structural, etc.? And where does the material go and all of that? So we have a lot of decisions to make, but creativity is going to be an important ingredient. So I want you to consider this point, that demolition can be the single most wasteful decision you make in your lifetime. And so I'll give you an example. EPA says that on average we dispose of about 4.4 pounds of waste every day, essentially throughout our life. So if you were to multiply that out over a 75-year lifespan, the total would be about 120,000 pounds. A lot of the buildings that we deconstruct, we try to get some estimate of what they weigh, and a typical 2,000 and some square foot home weighs about 120,000 pounds. So if you see the comparison there, you might, your entire life, you might throw materials away for 75 years, or you might make a single decision to demolish your home or building, and that single decision is a lifetime of waste. So that's just something to think about. Now, there are a lot of challenges to this decision. If we've decided to reuse things, it's not going to be easy. It's not like you can just go to the reuse Home Depot and have all your problems solved. So we've got to look at some of those challenges. Now, there's challenges to reuse of building materials. One of them is the supply. I'm going to put my practitioner hat on and say I run a reuse store, and that store is limited by what materials are available on any particular time. It's also in some ways limited by the demand. So if I have an opportunity to collect a bunch of materials and I don't have any demand for those materials, or I don't know of any demand, I'm basically putting my operation at risk. So reuse is really limited by supply and demand issues. And one of the points about demand is if you have built up the demand, it clarifies what type of supply you need to go after, and I think you can control your operation better. On the flip side, one of the things we do is we disassemble or deconstruct buildings, and we found out right away some of the limitations and challenges to deconstruction. There were buildings we really wanted to see deconstructed so that we could reuse all those materials and generate all those benefits from reuse. But the people that own the buildings were very concerned about how much time it takes to deconstruct or how much it costs to deconstruct compared to demolition. So those are kind of the top two challenges for deconstruction, the cost and the time. The picture on the screen there was a historic home where they had to be relocated 200 miles away. So we found an intermediate way of deconstructing buildings, which we called hybrid deconstruction. And that came from looking at how people were manually taking buildings apart and how demolition people were mechanically demolishing them, and seeing how equipment could help us save these assemblies, as you can see in the photo. So the next point is, you've decided to reuse. What is the reason you reuse? Well, a lot of the reason is you're looking to generate benefits, environmental benefits, or maybe social benefits, whatever that is. And of course, we're focused on carbon. So there's a hierarchy of reuse. And so the benefits that we're looking for, a lot of them come from saving that building in place, not completely removing it and replacing it with a whole new building, which has a lot of carbon impact, or carbon footprint. So the highest level you can reach is to save that building in place. Another similar level is to move that building. In this case, we're just showing moving a small shed. There's energy input needed to do that. Sometimes there's some waste generated, some recycling generated by doing that, but it is a close second. It also is very difficult to move buildings, and it doesn't often work. So we go to the third level, which is to reuse assemblies. And what I mean by that is, why would I, let's say, take a staircase apart when I could sell an intact staircase to someone for reuse? Or when you take that a step further, you say, well, what about engineered trusses if they could be recertified? What about wall sections? So we'll get into that a little bit more, but that's what I mean by reusing assemblies. Now, reusing materials is in there as well, and that would be to, you know, to fully deconstruct a building and save the doors and the 2x4s and everything else. So one of the important points that I bring up is that the current structures that we have today, the impacts of building those structures in the first place, those impacts have already been accounted for. Wherever we are, as far as the climate is considered, the impacts of building that old structure have already been factored into today's environmental conditions. So essentially what I'm saying is that current structures have been paid for. And the benefit of saving those materials is there's no additional impact or minimal additional impact of saving those materials versus creating new ones. I've seen some disturbing trends. If you look at where we've been going, we've taken down buildings. I've taken down buildings that are quite old. I've taken down newer buildings, and I see materials changing over time. It's no mystery to anyone that has ever looked at some old reclaimed wood and been amazed by the quality and character of it, and then compare that to newer foam trim or MDO or something like MDF trim or something like that, where you see the difference in quality. So what we're seeing is in some of the newer buildings that we're taking apart, some of the materials are really lacking in quality, lacking in durability. In fact, it seems to me that a lot of the new materials that you buy today will have to be purchased 3 times compared to what materials used to be purchased, because they just don't last as long. And honestly, we're slowly becoming numb to that fact, where we assume we're going to have to replace these materials because that's just the way it is. And a couple of days ago, I was working on a building that's 157 years old, and that siding, which had sat out for years, unpainted in the weather, that was in perfect condition, it just amazed me compared to what you might buy today. So the rate of waste is accelerating, and no one seems to even realize it. Now we have to talk about what are the avoided impacts of reuse versus new. I just gave you one. If materials from the past lasted longer, then they didn't have to be replaced as frequently, and that's a benefit. It's also true that these materials have been paid for, so that essentially their impacts on climate have been already taken into consideration, and using them again doesn't add to that. So lower carbon emissions from saving these materials, keeping them in use. Embodied energy is preserved. You know, we invested energy in all these buildings. The energy had an impact on the environment, so why would we waste that energy, essentially, that embodied energy, by wasting the materials and starting over again? I consider that, I like to think that I've saved thousands of acres of forest land by saving the wood that someone would have to cut new trees down to manufacture it and then sell it. We're an alternative to cutting trees down. I have never cut a tree down in 25 years. Why would I? I have all of these essentially buildings full of trees that I'm saving so that you don't have to cut trees down. Landfill life is extended. We don't maybe worry about the landfill as much as, like, what about the next landfill? What about the fact that it's going to fill up and we're going to have to place a new landfill somewhere and have a new landfill to take care of for eternity? Okay, and the last point of this slide is that The Forest Products Lab conducted a study, and just to give you some numbers, they compared what is the difference between using reclaimed flooring and reclaimed framing members compared to manufacturing new flooring and new framing. And what they found was, in a quick summary, that by salvaging the wood, you saved 11 to 13 times as much energy, and you generated 3 to 5 times less greenhouse gas emissions. So there's absolute definite benefits to salvaging materials, and those numbers show that. So here we have a picture of a warehouse. This is a building that we would typically deconstruct. It's got some nice beams in it, plywood posts, overhead doors, things like that. This would be a great structure to deconstruct, assuming it had to come down. We don't want to take it down, but if that's the decision someone's made, then we're going to do the best we can to mitigate that impact. One reason I use this image is that we actually have started to look at buildings as standing warehouses of supply. So that warehouse, essentially, it could be taken apart and formed into piles of reusable product. And we look at it as essentially the warehouse itself is a warehouse of reusable product. So one important point of that is that if we know about a building early, we can treat it like it's already in the warehouse, if you know what I mean. So, okay, now there are lots of benefits to reuse. One of the benefits that we focus on a lot is owner reuse, where we try to get the owner to reuse some of their own materials in their new structure. That's assuming that it's been decided by others that there will be a new structure. Of course, we try to get them to reuse the materials and reuse the structure. If that's been eliminated, then we try to get them to reuse some of their materials on site, which is the most sustainable thing that they can do at that point. Now, this is a comparison that we do when you compare demolition and deconstruction to help people in deciding what they're going to do, deciding to save a structure intact or in part. So one of the things that I think demolition comes in, and they sell themselves as we're the fastest removal option, and that to me is not a great argument. But they say we're the fastest. We also consider ourselves to be the cheapest option. Demolition would be often considered the fastest, cheapest option. So, but when you think about it, if you pay to demolish a building and you pay the full cost of disposal, and then you have to go out and buy everything that you just threw away all over again. So when you hire someone to deconstruct the building, you have the potential of reusing your own materials. So you're paying for deconstruction. Maybe that initial cost is higher. But in reality, if the benefit of deconstruction, there's no benefit of demolition. But the benefit of deconstruction is that you could have all of these materials returned to you, and that could benefit you financially because you don't have to go buy them again. When you do the math of that equation, you find that deconstruction often is the cheaper option. So this is a slide on commercial reuse. So this is a project I'm dealing with right now in the Seattle area. It's 285,000 square feet. It's a really challenging project simply because the materials that we're generating there are commercial materials, and they are specific materials that in some ways require a specific buyer. The buyers of materials like this are hard to find because people who have buildings of this size and this type are not often looking for used materials. They're looking for new materials to maintain a certain style, to maintain a certain quality level. They're really concerned about labor costs and things like that. So this is a project where our quote unquote warehouse full of materials here will not be reused unless someone chooses to reuse them. We can't just magically save 30,000 ceiling tiles and hope that someone will buy them. So as far as the reuse marketplace, there are a lot of challenges, and one of them isn't to gamble on these materials if no one else is looking for them. So we need the demand. We need people to consider reuse when they're purchasing materials. I started realizing the benefits of saving assemblies instead of completely disassembling materials. One of the benefits is that if I don't have to take it apart, I save labor, I save time. If you don't have to put it together again, then you save labor and you save time. So we have started taking orders, and we've been doing this for years actually, where someone creating a small outbuilding or cabin or something like that, they may order up wall sections, floors. So if you needed an 8x12 shed, I could cut you 2 walls that are 8 feet wide and 2 walls that are 12 feet wide, and then I would literally cut out an 8x12 section of floor, and you'd be well on your way to building your 8x12 shed by just buying those 5 assemblies, those 5 panels. So that's what we call, instead of calling them prefabs, we call them postfabs. An example of that is this project where the owner chose to reuse their own sections, their own postfabs. And so they were removing a larger structure, and then they had use for a smaller structure that they were going to have on the same job site. So we actually were able to remove sections of the roof. We were able to remove sections of wall and the floor, and those sections were actually transported off-site for a time, and then retransported back to the site and constructed into a small storage shed. But the point is that when they did the math, they found that it benefited them financially. And a lot of times when we're focused on this, we're not focused on the environmental benefits enough. And it's because the buyers our clients are often not focused on their environmental impact. They're not focused on the environmental benefits of their choices. They often try not to focus on that because since demolition is the standard practice, no one wants to think about that because it's such a negative all around. So, but in this project, it's just an example of how carbon was sequestered, embodied energy was saved, materials were conserved, resources were conserved. So, just briefly about kind of some trends in deconstruction and reuse. Cities are starting to catch on. They are starting to look at the bigger picture benefits of reuse, and they're seeing job creation, they're seeing historic preservation, they're seeing the benefits to the environment, they're seeing the benefits to health when it comes to concerns about lead and asbestos and demolition practices. So Portland, Oregon has made the decision that any house or duplex in the city of Portland that's 100 years old or older, it has to be deconstructed. They're talking about increasing that date from 100-year-old to somewhere in the 1930s and older. So Milwaukee has now started their ordinance, and there are similar ordinances in Vancouver, BC, and other cities. And there are other cities that are considering doing this. So I just have a couple more slides. What are, how are we going to achieve this material reuse, and what are some of the barriers? So I have a comparison, success and failure. If we want to be successful, we need to allow time. Time is required to come up with these creative solutions. Time is required to find homes for these materials. If you fail, it might be because you didn't allow enough time. We need to control the costs of deconstruction by coming up with ideas like hybrid deconstruction or not handling things twice. Failure usually relates to bidding on something and not having a good enough plan, and then the costs of deconstruction and reuse are too high. Supply is managed or supply is mismanaged. We need to, that's part of time, is being able to have the time to manage your supply and demand. In our case, we try to build up demand for something like bricks before we ever get a brick building. So if we already have people waiting for 100,000 bricks, when we get 100,000 bricks, then you can see how that makes everything better for us. And then, of course, we can't control this, but the better quality materials, the better reuse works. So the final slide is that, we need creativity, we need time. When it came to something like this roofing, it almost could be written off as just something you can't reuse and that you need to just move on and look on to something else. But to me, it looked like, honestly, the most reusable thing in the building, because we cut out strips of it. We cut out 9-foot by 20-foot, 50-foot, 100-foot strips of this roofing, roll it up, and it is extremely useful for people that need something greater than a tarp or cheaper and easier than asphalt shingles. So this is something that the people that created the product probably never thought that their product would be reusable, at least in part, because it's a 10-foot wide sheet that becomes 9-foot. But it is something out there. We're having to be creative because these materials weren't meant to be reused. And I think that that's something that Brad specializes in, which is thinking about how to reuse things, before you build the building, like designing for disassembly and so on. So I'm going to hand it over to Brad, and he's going to be talking about metrics related to carbon.
Great, thank you so much, Dave. So our next speaker is Brad Guy. Brad is an assistant professor and director of the Masters of Science and Sustainable Design program in the School of Architecture and Planning at the Catholic University of America in Washington, D.C. He is also associate director of the Center for Building Stewardship, chair of the Sustainability Committee, and faculty advisor to the USGBC Student Group. Brad is the chair of the U.S. Green Building Council Materials and Resources Technical Advisory Group, member of the board of the Off-Site Construction Council at the National Institute of Building Sciences, and a member of the Sustainable Sites Initiative Materials Committee. Brad recently organized the Reclaim and Remake International Symposium in 2013, which hosted speakers from 23 universities in 8 countries on the themes of building materials reuse. So thank you for joining us, Brad, and take it from here.
Thanks for having me, Tina and Larry. And that's a little out of date, so I'm no longer in the MR tag for lead. I'm actually on the Social Equity Working Group in that. So I'm just gonna, this is really related to a lot of things that Larry and Dave talked about, and really trying to put metrics to these aspects that were discussed. So the themes I'd like to talk about are, of course, reuse is what we already have. There's a very different paradigm here compared to new materials. When we generally look at new materials, the manufacturing is the largest impact. But for reclaiming and reuse, there actually is no manufacturing, so other impacts become more important. We think a lot about waste and avoiding waste, but actually the substitution of materials is very, very important, and how holistic reuse can be, and try to put metrics to that as well. I think Larry made the point, we have to start with whole building reuse, but to make this connection that it is also to provide materials for adaptive reuse that might be compatible, and to really respect every scrap. So I like to think of it as, well, we can think at the large scale, but in an everyday context, everyone can reuse. We all do this in our daily lives without even really thinking about it. And the aggregation of that can end up becoming a very large scale, as I think Dave alluded to. We know the benefits sustainably for reuse. So here we're just going to focus on carbon for the sake of this forum. So I have 3 studies. I tried to put these in the continuum that I just mentioned. So looking at demolition versus deconstruction from an environmental LCA perspective, looking at the carbon footprint of a reuse operation. Actually happens to be community forklift here in Washington, DC area. And then using LEED credit scores as a way to ask some questions about building reuse versus new construction, and how they might shake out comparably in terms of energy performance, site benefits, and other benefits. Okay, so what are some of the questions we might have about deconstruction and demolition? So time was mentioned before. That's a big factor when we think about this, how much we can actually recover. But what we typically don't measure truly is the CO2 and embodied effects. And that's the kind of metrics that we need going forward. And then how can we make this kind of break-even point? So what are the real effects, and what kind of decision-making might result? It's no surprise that salvaging or deconstructing a building takes a lot of time. It takes a lot more time than demolition, even for the use of machinery. So thinking about support machinery that goes into the project, and all of this is burning diesel typically, or some other kind of fossil fuel. I was actually a little surprised to learn from the study how important transportation becomes. So again, if you think about the manufacturing inputs are 0 in this life cycle of a product, if we're assuming we're producing products from deconstruction, then transportation actually becomes a pretty important factor. And further, for deconstruction, if you're spending more time on a site, you are actually transporting workers quite a bit more than a demolition, which is a very fast process. In this particular project, a lot of times, of course, buildings that are slated for demolition are not in the greatest shape. So we're not deconstructing brand new buildings. We have older buildings, and we're trying to get what we can out of them. So even at this very modest scale of only 43% reuse that we could achieve in this project, you can see there are still significant landfill impacts from the deconstruction. But demolition is basically disposal. So it's the removal of a building resulting in disposal. So those impacts are very high in terms of quantity. And then you can see that salvage, of course, is really all for deconstruction and 0 for demolition. Okay, so here's the irony. The things that we pay for, like equipment, time, and labor, are the impediments, as Dave mentioned. But if we look at it from a CO2 perspective, they're actually not really the biggest impacts. So we kind of have a perverse situation here, as we all know. The environmental effects from not recovering materials are in the disposal of those materials, and the benefits are in the recycling and salvage by a very large we just look at this as kind of a relative chart, although the numbers are there, you can see that it's many times over these effects of the environment versus the idea of time and labor and so on. And so disposal is a very large greenhouse gas source from demolition. Salvage clearly is the debit, the credit. So we are assuming that we're avoiding new materials by using these materials again. And then there are still impacts. So the interesting thing here is we only had 43% reuse. So we actually didn't achieve a kind of net balance. Although the demolition caused about 7 times more greenhouse gas emissions than the deconstruction, the deconstruction still had impacts. So just for the sake of this presentation, I did a what if. What if we just improve the efficiency by 12% and actually getting to a threshold, let's call it 55 or 60% recovery. In terms of net impacts, it's 0. The deconstruction literally pays for itself in avoided impacts. The next case study is looking at the carbon footprint of the reuse operation that I mentioned here in DC. So the questions to ask, is there a benefit to having a reuse facility? Is it a carbon sink, was my question. How could this facility communicate an environmental message? So your $1 purchase, your one $10 donation to our firm would actually result in this kind of benefit. And then for their own use, how could they look at their environmental effects and make improvements in their operations? I think it's really important to just emphasize this the basic idea. What are the impacts of materials? They're vastly in the simple production, and things like transportation, the construction process, and even disposal are a very small part of the total life cycle greenhouse gas of a typical product. And we're not even sure if there's going to be a recycling benefit or not. The default is typically disposal. But when we recover something, while we may increase something like the transportation effects of doing that, what we're doing is literally sort of mirroring the process. So it actually, I didn't realize this was going to happen until I drew it, but if you just take away one thing here, it's the idea that reuse is like a mirror. It's really like a flip of the effects of the built environment. And perhaps we can think about that reflection back onto what we have as a way to go forward. But the pinch point is that middle piece. So we have to make the connection between having materials and making them available. So in the life cycle assessment, really a carbon footprint assessment using scope 3 parameters. Interestingly enough, the largest impacts were the store itself trying to pick up materials from the local community. So they would drive a truck about 60 miles a day, every day to pick up donations. And that was actually their largest operational effect. Also surprisingly, with the white goods that they collect and the metals they might have around, recycling benefit of just having those and sending them off to a scrapyard also was a very significant benefit for them. But of course, the reuse overall was the largest benefit. So between recycling and reuse, they're actually avoiding about 800 metric tons of CO2 equivalent per year. And if we net that out, that's about a minus 309 metric tons of CO2 per year for this store. And what is that? Looking at EPA calculator, that's about 66 passenger vehicles off the road in a year. That's avoiding 33 homes energy use for a year. If we wanted to think about it in more sequestering terms, about 8,000 tree seedlings grown for 10 years, or 364 acres of US forests sequestering carbon in 1 year. So I think the first point is proven that reuse is a sink. And if we want to think about ways to subsidize, and we need to always think about other ways to value, the carbon benefits are pretty clear. This last study is looking at LEED projects, version 2 and version 3. My questions here were, okay, we know there's a benefit to adaptive reuse, but what are the overall benefits? Are these buildings performing at least as well in terms of energy? Are there other kind of characteristics like the site or indoor environmental quality that might be better or worse? We need to kind of look at this from a holistic perspective. Back to the point Larry made, so sort of summarizing this, about 82% of commercial buildings in the US are older than 25 years, so 22% are older than 50 years. At any given time, we have about 2 billion square feet of vacant building in this country. So it's not even like we have to kick somebody out. There's a bunch of buildings sitting around just waiting for somebody to use them. It's also worth noting, so amongst the projects I looked at, about 2,000 projects here that achieved the building reuse credit. On average, they were doing about a 75% renovation as measured by the LEED system. So core and shell, I had about 1,500 projects, 200 were adaptive reuse, 1,300 were new construction. I don't know if you'd be surprised, but in version 2, actually, the core and shell adaptive reuse were achieving higher energy reductions on average than the new construction projects. In version 3 of LEED, the new construction projects caught up, basically. And on average, across the board, these projects were achieving about a 25% energy reduction. I should note, between version 2 and 3, ASHRAE 90.1 changed, so I did normalize the credits against the change in the energy standards. Are you surprised that for site characteristics, the adaptive reuse projects on average achieve more credits, statistically significantly? So for example, 90% of the core and shell adaptive reuse projects achieve the public transit access compared to only 70% of the new construction projects. Where the adaptive reuse fell down a little bit is on daylight. So I used that as a proxy for environmental quality. And also, of course, it has effects for energy. But if we kind of go back to the previous slide, seeing that the core and shell were doing better overall on energy, somehow that wasn't necessarily affecting them on energy performance. For new construction and major renovation, it's a little bit different. The adaptive reuse projects didn't score quite as well on their energy reduction, both across the board from version 2 and version 3, but you can see that all projects are getting better, so we can be heartened that LEED is either facilitating this or the energy codes are, or it's just happening anyway. So even the adaptive reuse are also getting, and the difference is not high. This is about a 5% difference in energy performance. But the same trend continues around the urbanity and other benefits. So density and connectivity credits, adaptive reuse always score better. New construction's caught up. So is that maybe doing more demolition in urban areas, or is that increase in public transit? This doesn't answer that question, but they are at least equal in terms of the environmental and greenhouse gas benefits of access to transit, while daylight remains kind of in a similar state. So just to summarize, we know that salvage takes more time, and the things we pay money for are really sort of a perverse measure. And when we look at it from a greenhouse gas metric, there's no comparison between reuse and other forms of building disposition. Reuse is a carbon sink. I've heard talk about trying to use carbon offsets around building improvements, and I think the more we can sort of illustrate that actually that is a kind of investment that can be made would be good. And the locality, so we know things about historic character and urban areas, but reuse is local, and there's a lot of reasons for that. But ultimately, it's also reinforcing, I think what Larry alluded to, that we're building the assets within that community. And building reuse isn't necessarily going to cause a lower energy performance, given all things equal, not necessarily striving for some net zero energy. But there's way more to reuse than just the building in community contexts. So we need to work on carbon offsets for the reuse of materials and buildings. We need to understand the scope of reuse in the US and really get robust data around cost and benefits. I think we really need to work on PCRs and EPDs for reclaimed materials so they can be in that system. And when we do those analyses and we see how, sure, maybe transportation goes up as one impact, but manufacturing basically goes to zero, we can really understand the differences between new materials and reused materials. And buildings are materials banks. They are a stock. And very excited about working on a new ISO standard for design for adaptability and disassembly. And that should be coming out the next year, and hope that would help guide some of this forward. So thanks very much.
Great, thank you so much, Brad, and thank you, Larry and Dave, for joining us today. Before we move into Q&A going until 10:15, I just want to highlight that our next webinar will be September 21st, and that'll be led by the LCA Data and Tools Task Force. So I've included a link here to register, and don't worry, I'll send this out to all participants today after this. Reminder too, you can receive AIA continuing education credit, so please send me your full name and your AIA member to get that. So with that, we will move to Q&A, and if you can't stick around, thank you so much for joining us today, and we'll be sure to post a recording on the website later this afternoon. So our first question was for Brad. Let me pull that up. So Brad, somebody asked, what is a typical pro forma for a reuse building versus a new construction building? Are the returns the same consistently, more or less?
I'm not a financial analyst, although I read actually just yesterday in a newsletter from the real estate industry, they're trying to push a separate investment category for adaptive reuse. And the figure was given that actually on average, adaptive reuse projects cost 25 to 30% less than new construction. I can only kind of tell you that tidbit that I got secondhand. And, you know, if we think more broadly about, say, heritage tourism and kind of market forces around cities and the fact that something like 70% of the world's population will live in cities by 2050, I would think the investment is pretty good, not being a financial person.
Great, thank you, Brad. And our next question was for Larry. Larry, how can we make reuse and energy upgrades part of our climate action plans for cities, states, and institutions?
I'm not sure. I was the one that I have this question forever about how to make this happen, and it's not even on most people's radar. They're focusing on getting new buildings to net zero and increasing energy and all that. And I think that one of the difficulties for cities is that when you do a climate action for your city, you're looking at the climate impacts from your city and the impacts from materials to build new buildings, which is the benefit you're trying to avoid building new material, using new materials. The materials are manufactured elsewhere. So we have to start, I think, thinking about CO2 emissions not as, they're not really local doesn't really matter because it all affects the planet. So the material may be made hundreds of miles away, but if you're using it, you should have to count, you should be responsible for that impact, not the person who made the material. In the same way that operational carbon, the power plant produces the carbon, but you're the one that's using it, so you should be the one that spends the carbon. So I think we just have to change the mindset of people planning these climate action plans to recognize that there are these benefits they could add to their climate action plan if they could include reuse and avoided impacts of embodied carbon from building new buildings. They would have a much better chance of meeting their climate action goals if they could actually count that as a negative or a positive benefit. So I don't have an answer. I just think we have to start reminding people doing climate action plans that they're missing a huge potential opportunity to improve their climate action plan by focusing more on reuse, and they're not doing this. This isn't just cities, it's universities, campuses, large portfolio holders. Obviously, if there was a price on carbon, a lot of this would be a lot easier.
Great. Thank you, Larry. And Brad, there was a follow-up question for you based on your last answer. Someone wanted to know, could you repeat the source on cost for renovation?
Oh, well, I'd have to look back up if I could send that to you, Tina, or something.
Yeah, sure. So Brad, and for all of our speakers, if you want to send me any resources, I will put it all in a list and send that out to everybody here today.
Great.
We'll get that to our participants. And so the next question is for Dave. Dave, what is the most important factor when considering all aspects of reuse on my upcoming project?
Is he still muted?
I think we may have, oh, there he is, Dave. Let's see, get the audio. All right, well, we'll loop back to Dave. Oh, Dave, you should be able to talk now.
I lost connection there for a bit. So what was the question?
No worries. What is the most important factor when considering all aspects of reuse on an upcoming project?
Well, I think I mentioned in the talk about creativity and time. So we can't, at this level anyway, it's hard for us to force reuse. You know, it's not like recycling where you have you're pretty sure that you can recycle something and you can plan for that. We really do need time to find homes for, like, those ceiling tiles, for example. You know, 30,000 ceiling tiles. I mean, if you just said, hey, we need you to come next week and remove them, there's literally no way to do that, because even if I could do that, I wouldn't want to do that. You know, I wouldn't want to have all that material. So it comes, you know, creativity and time. You want to be creative and think of ways to reuse this material, hopefully reusing it yourself. And then also you want to allow time so that we can build up that demand for something before we actually have to handle it.
Great, thank you, Dave. And we have one more question for Brad, and this is a good way to close out the discussion. Brad, how do we make building and materials reuse compelling enough to move it forward?
So I was recently at a conference hosted by the NAACP about centering equity in the green building environment. And it was a really good reminder to me of, you know, we often speak to each other and we have language, those of us in this field or the construction field in general, where we're not really thinking about how we can communicate to broader audiences. So two things that really stuck with me is, although climate change is going to kill us all, perhaps, it's very abstract and very far away. And what resonates with people is about their own lives, the intersections of climate change and their own vulnerabilities and their own cost and their own suffering or pain, whatever it is. So the message needs to be brought down, I guess you could say. I think the other important idea is having stories, because people just listen to stories, but we have to have the data behind the story. So maybe one way to communicate is start with a story and always have the data to back it up and to augment that story. And perhaps always having both will be the way that we can make this work.
Great, thank you so much, Brad, and thank you again, Dave and Larry. Thank you all to all of our participants for joining us today. If anything in particular struck your interest and you want to learn more or you want to get involved, consider joining the Reuse Task Force. If you would like to join the task force, just shoot me or Larry a note and we'll add you to the group. So thanks again, and we hope to see everyone at the next one. Thank you.
All right, thanks, everyone.
Great, thank you.
Thank you.